Whenever we see a system that reacts, like in this case that robot, when we're trying to figure out how it does it, we tend to assume it's all going on inside the machine. Like if we see a dog chasing a rabbit, for instance, we're assuming that every part of the dog's behavior is based in the dog's brain. So if we were trying to model that behavior, we would build a really complicated model that would explain all of it and then cram it inside the robot. But that's not what happened. What actually happens is it's interacting with its environment in its own way, and we tend to make it more complicated than it actually is. We call it the law of uphill analysis and downhill synthesis. If we look at the machine without knowing what goes on in it and we try to analyze its behavior, we build a really complicated model. If instead we build something, in this case that robot, very, very quickly, a simple machine, and just let it loose, it's really simple because we built it, and it's very easy and fun, and we get that rich behavior for free without having that complicated model that we'll have to explain later. I just exploit the fact that we tend to think it's more complicated than it is when I act and tell it and speak to the robot. I know what's going on, and everybody else thinks that's part of the robot. It isn't. It's what makes things a lot of fun in our lab.